Tonight's lecture is over environmental policy. There is a point of no return halfway into the 9-hour flight from New Zealand to the Antarctic. Once that 4.5-hour mark passes, if something goes wrong with the plane, there's nowhere to stop in the Southern Ocean for repairs. Susan Solomon is very familiar with that trip's all-important midway point. During her very first flight to the southernmost continent, the pilot told the passengers that their plane was not working properly. The front ski at the nose of their C-130 was frozen and couldn't be lowered into position, so landing on the packed snow at the Antarctic Research Station would be impossible. They had to turn around. This was in August of 1986, late in the winter in the Antarctic. And Susan Solomon, an atmospheric chemist, was on her way to investigate a mystery. She and a team of scientists from various institutions were gathering at McMurdo Station for a highly coordinated research expedition to tackle a question of global significance. Why was the ozone layer above the South Pole disappearing? On her very first excursion to Antarctica, Solomon and her colleagues collected the data that would eventually grab the world's attention and resolve an ongoing, hard-fought scientific debate that was taking place on an international stage. That debate was not only over what was causing the ozone layer to thin, but also over what exactly humans should do about it. And that brings us to key concept number 1, stratospheric ozone depletion caused by chlorofluorocarbons, or CFCs, and other anthropogenic chemical pollutants increases our exposure to dangerous ultraviolet radiation. So the Earth's atmosphere, the blanket of gases surrounding our planet, is made up of discernible layers that differ in temperature, density, and gas composition. The lowest level is the troposphere. This level is familiar to us. It is where our weather occurs, and it contains the air that we breathe. So most oxygen in the atmosphere exists as O2, that is, 2 oxygen atoms bound together. In contrast, ozone, or O3, is a molecule that is made up of 3 oxygen atoms. The vast majority of this unusual form of oxygen resides in the stratosphere, the layer of the atmosphere that lies directly above the troposphere. There, ozone exists as a thin layer called the ozone layer. A form of air pollution known as ground-level ozone, a component of smog, is found in the troposphere and should not be confused with the stratospheric ozone. Earth's atmospheric ozone layer protects the planet from much of the sun's ultraviolet radiation. Excessive exposure, especially of the most dangerous type to reach the surface, UVB radiation, can cause human health problems such as cataracts and DNA mutations that can lead to skin cancer. It also hampers plant growth, interferes with embryonic and larval development, and hinders reproduction in many species. This impact could disrupt community connections and impair ecosystem functions. So normally, stratospheric ozone is continuously created and destroyed, alternating between O, O2, and O3 in a natural cycle powered by UV radiation that keeps overall O3 levels constant. In this region of the stratosphere, UVC is absorbed by O2, breaking into 2 oxygen atoms. Each of these can bind to another O2 molecule to form O3. Ozone molecules absorb UVB radiation, breaking them back apart into O2 and O to continue the cycle. This absorption prevents most UVB and all UVC radiation from reaching Earth's surface. However, O3 molecules can also be broken down by some industrial chemicals, including chlorine-based refrigerants such as chlorofluorocarbons, or CFCs, and hydrofluorocarbons, or HCFCs, as well as bromine compounds used in fire extinguishers and pesticides. These are known as ozone-depleting substances, because they break down ozone faster than it is formed, which in turn causes the ozone layer in the Earth's atmosphere to become less concentrated or too thin, forming what is known as the ozone hole. This breakdown is more likely to happen when two requirements are met: a great deal of solar radiation and ice crystals that can act as a platform on which the CFC molecules can be broken down. Early spring provides these conditions. The sun has returned to the area, but it is still cold enough to provide the ice crystals that facilitate the breakdown of CFCs. The hole in the stratospheric ozone layer over Antarctica is therefore most pronounced during September and October. That is springtime in the southern hemisphere. A similar but less severe hole forms in the Arctic, which is not as cold as Antarctica, during the northern hemisphere springtime. Because stratospheric ozone is so important to life on Earth, uncovering the cause of ozone depletion so it could be addressed quickly became a quest of international urgency. Even though CFC molecules are very stable and do not break down in the troposphere, when they eventually reach the stratosphere, exposure to UV radiation breaks them apart, releasing a chlorine atom. This chlorine atom then breaks apart ozone, forming chlorine monoxide and O2. This reaction happens again and again because chlorine is easily released from chlorine monoxide, making it available to attack another O3 molecule. Solomon's team found the evidence they were searching for: chlorine monoxide in the atmosphere. There is no natural source of this molecule. It could only come from the breakdown of CFCs. In 1988, they published the studies that would provide the definitive link between CFCs and the ozone depletion. In a way, this was good news. Since CFCs were human creations, we could simply stop creating them and stop using them. Fortunately, by the time that research was made public, the wheels of policy were already in motion. And that brings us to infographic number 1 on page 219. Earth's atmosphere is composed of layers that differ in chemical composition. The stratosphere contains a region with more ozone than other parts of the atmosphere, and this is called the ozone layer. Ozone is important because it reduces the amount of harmful UV radiation that reaches the Earth's surface. A variety of chemicals, such as CFCs, destroy stratospheric ozone. And that brings us to key concept number 2. Environmental policies protect the environment and human well-being. When environmental problems transcend national borders, international policies are needed to address them. The development of CFCs back in the 1930s had been a cause for celebration among scientists. These new industrial coolants were far less toxic than the ammonia and sulfur dioxides that were being used at the time, and there seemed to be no limit to their possible uses not only as a coolant in refrigeration and air conditioners, but also as a key ingredient in aerosol sprays and as a stabilizing substance in styrofoam food containers. Like most American children of her generation, Solomon spent her childhood surrounded by CFCs. By the time she had reached graduate school at the University of California at Berkeley in the late 1970s, they were truly ubiquitous. But at that point, scientists were beginning to raise alarm bells about the link between CFCs and ozone depletion. They didn't yet have definitive evidence of the connection, but they also felt they couldn't wait for certainty to take action. So they began pressing legislatures to create policies that would limit or eliminate the use of suspicious chemicals such as CFCs, HCFCs, and some others, just in case they were, as scientists suspected, responsible for ozone depletion. Environmental policy refers to a course of action adopted by a government or an organization intended to either restore or protect the natural environment and resources, sometimes by repairing damaged ecosystems, or other times by reducing or mitigating the impact we humans have on our planet. In many cases, the protection of human health and welfare is at the heart of environmental policies. Clean air and water aren't just good for the environment, they are also necessary for human well-being. So environmental problems are often wicked problems. That is, they tend to be very complex. They have multiple causes and consequences and multiple stakeholders. Most of the biggest environmental issues that we now face, like pollution, species endangerment, and climate change, are also transboundary problems. In other words, they occur across state and national boundaries. Therefore, solving them requires the cooperation of individual states and nations around the world. CFC-driven ozone depletion is one such example. CFCs released in the United States, Europe, and other regions were affecting stratospheric ozone over Antarctica and the southern tip of South America. This reality makes environmental policy tricky, in part because what is best for one group is not always best for another. For example, sometimes a decision that is profitable for a business to use a resource without regard for renewability or to release pollution rather than taking steps to eliminate it can harm people and other species who do not benefit from the business transaction. Economic choices may need to be moderated by policies that prevent abuse of resources or that cause environmental or societal harm. Policies are especially important when dealing with commonly held resources such as the atmosphere or the oceans. Since no one owns these resources, there is a tendency to use them or do things that harm them because no individual or group bears the total cost of the damage. Most successful environmental policies involve compromises, and the agreed-upon choices come with trade-offs. Still, despite these hurdles, there are many successful environmental policies in place, including those with such far-reaching goals as limiting pollution or habitat destruction, restoring damaged environments, and managing commonly held resources such as rivers or public resources such as national forests in a way that avoids the tragedy of the commons. Other factors also make formulating and following through with environmental policies difficult. Those who suffer the burden caused by environmental degradation are often not the ones who caused the problem in the first place. We are disconnected from the outcome of our actions and may not know that what we do is harming someone else. There is often a significant lag time between the effect of an action and that action. It takes a while for enough pollution to build up in the air or water to cause health effects, for example. And most impacts have multiple causes, so it is difficult to identify the role of each cause. For example, many things cause cancer, including environmental exposures. As early as the 1970s, scientists involved in laboratory studies on CFCs and ozone began calling publicly for an end to CFC production. Their argument that society should not wait until the link was definitive before taking some precautions was a long shot. At the time, there were very few laws on the books designed exclusively to protect the environment, and certainly none based on an unconfirmed hypothesis. But it turned out right at that moment. The U.S. federal government's approach to environmental protection was changing dramatically. And that brings us to infographic number 2 on page 221. Public policy in general is a course of action adopted by a government or an organization intended to enhance society as a whole. And that brings us to key concept number 3. Many iconic U.S. environmental laws originated in the 1960s and the 1970s and became models for similar laws worldwide. Some of these laws allow citizens to sue the violator or government to ensure the laws are properly enforced. So before the 1960s, environmental policies mostly dealt with how to best use resources. Addressing pollution or environmental damage was not a key objective. Furthermore, environmental problems were primarily handled at the state level because federal environmental regulations were considered an intrusion on state sovereignty. In fact, most environmental problems were addressed only after the fact through litigation, an arrangement that too often favored the polluters. It was even more difficult back then than it is today to prove that toxins from a factory or a dump that had seeped into the water or permeated through the air were killing livestock or causing human illness. Eventually, though, things began to change. Industry grew, and so did pollution. And, as it did, environmental problems began slipping across state lines so that water and air pollution from one state affected another. In the 1960s and 1970s, a massive national outcry forced legislatures to acknowledge that cohesive federal policies were needed. New laws were passed, and existing environmental legislation was updated. Regulators began to set environmental performance standards, also known as pollution standards, by identifying the levels of pollutants allowed to be present in the environment or released over a certain period of time at the federal level. By determining how much pollution could be released in the first place, environmental regulation shifted from an after-the-fact litigation to prevention. The shift proved effective. Water and air pollution from industry began to drop. So by the 1970s era, the modern environmental policy had begun. On January 1st of that year, the National Environmental Policy Act was codified into law. NEPA established environmental protection as a guiding policy for our nation, mandating the federal government take the environment into consideration before taking any action that might affect it. For example, NASA commissioned the first of several studies to evaluate the impact of rocket fuel on ozone depletion. In NEPA's wake came a wave of iconic legislation, including the Clean Water Act, the Clean Air Act, and the Endangered Species Act, all passed with overwhelming bipartisan support. Environmental laws are amended as needed. For example, in 1990, the Clean Air Act was amended by Congress to address new threats to air quality, such as acid deposition and the ozone depletion. So all major environmental laws also have a mechanism that allows individual citizens or groups, including state governments, to demand enforcement. The citizen suit provision. Violations can be reported, and if they aren't dealt with in a timely or satisfactory manner, the citizen or group can file a lawsuit against the violator that has allegedly failed to uphold the existing law. So lawsuits can be filed against an individual, a private company, or the government, including any regulatory agency mandated to enforce regulation. While there have been many victories for those filing citizen lawsuits, even more have ended in rulings that favor the defendant being sued, and many others never make it to court. It is for this reason that the most successful lawsuits are filed by professional organizations with staffs of lawyers knowledgeable about this process. U.S. environmental laws have been successful at improving the environment. Our air is cleaner, our water is safer, and our wild areas and wildlife are better protected than before these laws were passed. In fact, these laws became models for the environmental legislation in countries around the world. And that brings us to infographic number 3 on page 222. Many landmark U.S. environmental laws were passed, beginning in the 1960s, during a period of tremendous bipartisan cooperation and support for taking steps to ensure a clean and healthy environment. And please take a few minutes to go through this table on your own time. And that brings us to key concept number 4. Policy making includes systematically considering all options before setting policy and periodically evaluating policy after it is implemented. So NEPA did more than commit the federal government to environmental protection. It established a process for generating environmental policy that includes a scientific evaluation of the environmental problem and the consideration of various approaches to address that problem, including the economic and technical feasibility for each option. A decision is then made as to the best course of action. The process itself is responsive and allows for policy revisions as new or changing information comes to light. NEPA's signature feature has been the Environmental Impact Statement, or EIS. This is a report that details the likely effect of a proposed federal action, such as building a road or upgrading a nuclear facility. The goal of an EIS is to identify problems before they occur so that stakeholders can choose the most acceptable course of action. To keep the process transparent, the findings are made public and everyone is given a chance to respond through letters and public hearings. It was an EIS released in 1988 that first evaluated the health, societal, and environmental effects of potential regulatory actions to address ozone depletion. This document gave policymakers the information they needed to formulate useful, appropriate policies to protect atmospheric ozone. So in 1970, Congress established the U.S. Environmental Protection Agency to implement and enforce all the new federal environmental laws that were then being passed as part of a greater effort to coordinate environmental protection at the federal level. The National Oceanic and Atmospheric Administration was also created at the same time as part of the national strategy to safeguard the environment. The EPA and other agencies, such as the U.S. Department of Agriculture, follow the same NEPA process to establish rules and regulations in support of environmental laws. These agencies are administered by the executive branch, funded by the legislature, and subject to judicial oversight. The EPA sets rules or standards, such as performance standards, that ensure that the goals of any given law are met. They are also tasked with holding individual states and corporations accountable. The EPA works with states and industry to help them achieve compliance. But if a given entity fails to comply with a given rule, the EPA has the authority to step in and mandate changes. It can, for example, force a power plant to make upgrades that decrease pollution, close a factory for repeated violations, or fine an individual state for failing to curb its vehicle-generated air pollution. It can also force entities to pay cleanup costs, revoke operating permits, or bring criminal charges against violators. Of course, the EPA's reach only extends to U.S. borders. And as the case of CFCs shows, most environmental problems tend to stretch way beyond those. So I'd like to point out here that organizations such as the EPA are what we call extra-governmental. The people in these positions often command high salaries and they're not elected officials. So in that regard, I have to be skeptical of them. And I'd just like to ask you the rhetorical question, who watches the watchers? While your book is painting a rosy picture of these organizations, they are often ripe with corruption. For instance, Joe Biden's Secretary of Energy, Jennifer Granholm, provided false information about her family's stock holdings. Some of the stocks that her and her family owned were key players in the Biden administration's efforts to improve the environment. How is that ethical, good for the country, or good for the global environment? Why is it or how is it that people get into the government and become wealthier than they were before they went into it? Government officials are supposed to serve the people, not themselves. And that brings us to infographic number 4 on page 223. Policies are created and revised using some basic steps that allow policymakers to systematically evaluate the situation and possible responses. Regulations based on bills that are passed and signed into law are proposed and administered by regulatory agencies like the EPA in a similar manner. The process itself is responsive and allows for revision as new, changing information comes to light. And that brings us to key concept number 5. Sound science is needed for effective policy decision-making. Political lobbies, public opinion, and the press also strongly influence the process. So early on, the concerns raised by scientists over CFCs led to a U.S. ban on the chemicals in aerosol sprays. But when it came to further action, banning the chemicals completely, industry dug in its heels. The chemicals were in wide use by then in many different industries. They were useful and generated billions of dollars in profit for the chemical companies that made them and the manufacturers who used them. These business entities used their money and influence to argue against rushing to judgment. They insisted that there was far too little evidence to get rid of something so ubiquitous and important to the U.S. economy. The science community disagreed. Depending on high-quality science, that is, peer-reviewed studies with strong scientific consensus is crucial to good policy. Basing policy on what one would like to be true or on what would garner profit or political advantage to policymakers will not solve societal problems and may create new ones. Science is not a political construct or a belief system. By its very nature, the way scientific information is gathered, hypothesis testing, and reported peer-review publications has built-in checks against bias. Some people believe society, not scientists, must decide how to address the problems it faces, but science should be the basis for these policies. Indeed, in an ideal world, all policies would be based on sound science and established need. Legislatures would receive scientific information about a proposed policy from unbiased sources from the natural and social science community and use this to write bills. Once passed and signed into action, the judiciary would weigh in on the constitutionality of the new law, and rules to implement that law would be quickly set. But that's not quite how it works. The science is often hard to distill into feasible actions, and getting timely policies into place can be challenging, with policymaking often proceeding at a snail's pace. To be sure, the scientific, legislative, executive, and judicial steps are a crucial and routine part of any policymaking, but there is another force at work too: political lobbying. So in the United States, and even on the international stage, political lobbying, that is, contacting elected officials in support of a particular policy position, is part of the democratic process. We have access to our elected officials and can share our opinions with them. Citizens and private organizations like nonprofits, labor unions, and industry groups lobby for or against specific proposals based on their own interests. Critics say that professional lobbying has grown alarmingly sophisticated and well-financed, making individual voices harder to hear and potentially interfering with policymakers' judgment. Besides running ad campaigns promulgating ideas that serve their own best interests, industries also contribute large sums of money to candidates for elected office, hoping to influence those candidates, if elected, to act in ways favorable to industry. Nonprofit organizations like the Natural Resources Defense Council or the Sierra Club also have professional lobbying divisions that promote their positions to elected officials and the general public. Taken together, these environmental nonprofits spend tens of millions of dollars per year in federal lobbying efforts, but their investments are still dwarfed by the hundreds of millions of dollars spent by industry. The regulation of toxic chemicals, for instance, is sometimes more heavily influenced by industry pressure than scientific evidence. The tobacco industry argued successfully for years that smoking was not linked to health problems, despite ample evidence to the contrary. Of course, it doesn't necessarily take money to influence policy. Citizens and grassroots movements can influence Congress by calling their representatives and making their opinions known, or by voting with their dollars, refusing to purchase products with impacts they don't want to support. And that brings us to infographic number 5 on page 225. Many organizations and individuals influence not only whether we institute a policy to deal with an environmental issue, but also the design of that policy, what it covers, and how it will be implemented and enforced. The wide variety of voices, many representing differing points of view, can make it difficult to create new policies. Though political ideologies might influence how one goes about addressing a problem, policymakers ideally look to the best available science when making decisions about whether a policy is needed to protect the health and well-being of the public and the environment. And that brings us to key concept number 6. Policy can be enforced with command and control regulations through economic incentives, market-driven approaches that favor preferred responses. So a range of policy tools are used to enforce environmental laws. Governmental command and control regulation is one approach. This option relies on setting enforceable regulations, identifying performance that constitutes compliance, and setting penalties for noncompliance. This type of regulation can take several different forms, like issuing permits to authorize operation of equipment or facilities that may pose risk to the environment, establishing performance or technology standards that regulate emissions or specify the practices that must be used to meet those standards, or simply banning the use of a given substance. For example, Title VI of the CAA gave the EPA the authority to regulate ODS. Along with other provisions, a phase-out program was established for ODS that were currently in use, with some exemptions for compounds with suitable replacements, and acceptable procedures were laid out for the destruction of ODS stockpiles. Alternatively, market-based approaches create economic incentives for the private sector to reduce environmentally harmful actions without dictating exactly how to reach a desired target. Economic incentives can be reward-based or punitive. For example, governments can reduce taxes by offering tax credits to consumers or businesses that pursue environmentally friendly actions, such as buying a hybrid vehicle or installing energy-efficient appliances. Or they can levy taxes based on the amount of pollution produced, a so-called green tax. For example, U.S. manufacturers pay a tax on the ODS they use, and this tax has gradually increased since 1995 as an incentive to reduce the use of these substances. Importers to the United States of any product that may contain ODS must pay a tax based on the weight of ODS in the product. One place you may experience such a tax is when you have your tires changed on your car. The person or the entity selling the tires will charge you a nominal fee for disposal of your tires. So another market-based approach used to implement the initial phase-down of ODS that began in 1991 was cap and trade. This policy involves setting an upper limit, the cap, on the use or emission of certain pollutants, distributing permits for a portion of that limit to each user, and then letting individual businesses freely trade or sell those permits if they have some of their allotment left over because they used or emitted less of the regulated substance. Violators are fined. In the cap and trade program that addressed acid rain, the fine was set at $2,000 per ton of emissions that exceeded allowances. Caps can be lowered over time to bring down the level of pollution as needed. An advantage of this approach is the freedom for plant operators to choose which avenue to compliance works best for them, reducing actual emissions or purchasing additional permits. One of the most successful cap and trade programs to date reduced sulfur pollution from coal-fired power plants, a major cause of acid deposition in the eastern United States. Targets were met ahead of time, and the program experienced almost 100% compliance. Very few fines were assessed. And it came in at a much lower price tag than predicted, demonstrating the power of market-driven approaches to pollution control. Carbon emissions are currently being reduced with cap and trade programs at the state and regional levels in the United States, as well as internationally, such as within the European Union. So, financial incentives such as subsidies, grants, and low-interest loans can also encourage environmentally beneficial actions that might otherwise be hard for individuals or businesses to afford. For example, the United Nations and some individual nations gave out subsidies to businesses to assist their transition away from ODS to more ozone-friendly replacements. Unfortunately, sometimes subsidies inadvertently support environmentally damaging actions, such as the health and environmental impacts caused by the heavily subsidized fossil fuel industry. In deciding which of these tools to use for any given policy, policymakers must consider several factors, including whether the tool will actually help attain the desired environmental goal, who will bear the financial cost and other burdens of the policy if this tool or that one is used, and how adaptable the tool itself will be to changes in the underlying policy. They must also establish clear methods of enforcement. Someone has to oversee the implementation of a given policy tool and hold the relevant parties accountable in a predetermined and straightforward manner. This can be done by assessing fines or penalties, or by revoking privileges, or in some cases, by charging someone with a crime. And that brings us to infographic number 6 on page 227. This table outlines policy tools, and I'd like for you to spend a few moments going over it on your own time. And that brings us to key concept number 7. International policy is established through treaties that range from a simple agreement that action is needed to protocols that specify procedures and targets for participants. Enforcing compliance for international treaties is difficult, but may include incentives such as technological or financial assistance, or disincentives such as economic sanctions. So even as the tide started to turn against the use of CFCs by various industries, industry itself had one powerful argument against a full CFC ban. If U.S. companies were forced to curb their use of these chemicals while other countries still use them, besides the ozone layer not being saved, American industry would lose its competitive edge as it scrambled to come up with replacement chemicals, a tragedy of the commons dilemma. For the ban to achieve its desired goal of protecting the ozone layer, industries in other countries needed to be held to the same standard. The efforts of individual states and countries are essential to environmental protection, but ultimately, global problems require international efforts. International agreements go by a litany of different names: treaties, conventions, accords, platforms, and so on. A convention is an international agreement that represents a position on an issue and identifies general goals that the signing countries agree to pursue, such as the protection of species or the wise use of wetlands. To lay out the specific actions that will be taken, as well as the time frame over which these actions must occur, a protocol is often drafted to set precise goals and targets. International treaties are drafted at meetings, often with intense negotiations, and signed by the attending representatives. The treaty must then be ratified by each nation. In the United States, new treaties are ratified by the U.S. Senate. Amendments or subsequent agreements can be signed by the President, though the Senate sometimes disagrees with the President as to what constitutes a new treaty. For multilateral treaties involving many nations, the draft may identify a minimum number of nations that must ratify it before it enters into force. This could take 1 or more years. There are currently more than 2,500 international agreements that pertain to the environment. They cover things like whaling, where and how much it can be done, endangered species protection, making certain habitats off limits to loggers or banning the sale of ivory, for example, and the conservation of global resources like the atmosphere. For any of these agreements to work, for the environment to be protected, signatory parties, countries that sign on, must keep their word and do what they say they will do. In other words, they must comply with the terms laid out in the agreements. Achieving compliance is even trickier at the international level than it is for individual countries or states. To be sure, international agreements often include mechanisms for tracking participants' performance around certain goals or promises and to catch failures of compliance early on. And most of them also have dispute settlement mechanisms in place that may include conciliation, that is, reduced targets or goals, negotiation to refine responsibilities, or binding arbitration. Economic aid or technological assistance might also help a nation comply, but few agreements have a robust capacity to enforce the established standards or to punish the participants who fall short of their promises. Incentives can help the participants reach their goals, And disincentives, such as penalties, stricter surveillance, and report requirements, trade sanctions, and even suspension of certain relevant privileges can help get participants back on track when they fall short. But those efforts may be ineffective if a country is not fully invested in the goals at hand. Including harsher penalties at the outset is difficult because it may mean that fewer countries ultimately sign onto the agreement at all. And that brings us to infographic number 7 on page 228. More than 2,500 international environmental treaties are currently in place, covering a wide range of topics from protecting wetlands and species to the use or disposal of hazardous materials. And that brings us to key concept number 8. The Montreal Protocol is successfully addressing ozone depletion thanks to a strong international commitment and the flexibility to update it as needed. So attempts to address ozone depletion on the international stage began in the late 1970s. After much debate and political wrangling, the 1985 Vienna Convention, a treaty that established the need to respond, was passed. This was followed by the 1987 Montreal Protocol on substances that deplete the ozone layer, a protocol that established a planned phase-out of CFCs and other stratospheric ODSs. By 2009, the protocol had been ratified by all nations of the world. Interestingly, the 1987 Montreal Protocol and the international commitment to address CFCs and ozone depletion came before Susan Solomon's final study definitively linking CFCs to ozone depletion was published. We didn't know all the details in 1987, but because the potential loss of our protective ozone layer was such a serious problem, we chose to take action. This is an example of applying the precautionary principle, acting in the face of uncertainty when there is a chance that serious consequences might occur. So as more information poured in, it quickly became apparent that the Montreal Protocol targets would not be sufficient to stop ozone depletion in a timely fashion, so the phase-out dates were moved up for CFCs. Amendments to the Montreal Protocol are still negotiated in annual meetings that strengthen the response, such as adjusting the target dates to phase out harmful compounds or adding new chemicals to the list of regulated substances. This ongoing process is an example of adaptive management, that is, allowing room for altering strategies as new information comes in or the situation itself changes. So within a decade or so of the Montreal Protocol's acceptance, scientists began to see evidence that it was working. The rate of ozone thinning in polar regions slowed down, stabilized, and eventually began to reverse. The data now suggests that the ozone hole is finally beginning to heal. This is defined as an observable increase in ozone. Based on the recovery to date, scientists are projecting that the Antarctic ozone hole will have fully recovered by 2050. Unfortunately, the story is not over yet. A 2018 study showed that the stratospheric ozone appears to be declining in equatorial and mid-latitude regions. This is especially concerning since many more people live in these regions than in the Antarctic or Arctic because these regions naturally receive more UV radiation. Scientists do not yet understand the cause of this decline. The Montreal Protocol represented the first and arguably most successful international environmental policy ever produced. The U.S. federal government brought environmental policy into focus in the 1960s. The world followed the nation's lead, and our environment is cleaner today than it was then. But that will only be true as long as we continue to uphold those laws and make new ones when needed. NEPA and the environmental laws that followed were passed with strong bipartisan support, but that is changing. The push to reduce environmental regulations in the United States has been increasing since the 1980s, and congressional votes on environmental bills now generally fall along party lines. Whether the United States and the global community will be able to agree on and implement effective policies to address environmental issues such as climate change is a story that is still unfolding. Our success at addressing ozone depletion shows that it can be done. However, the question remains, will we do it? This graph shows actual and projected change over time for total global emissions of ozone-depleting substances with and without the Montreal Protocol and its amendments. Adjustments to the phase-out schedule of various ODSs in the form of amendments represent the success of adaptive management in dealing with complex environmental issues. And that brings us to this chapter's core message. Environmental policies protect the environment and public health, define acceptable behaviors for individuals and groups, are challenging to achieve consensus because of the complexity of issues, and must meet existing problems and new problems that arise. In summary, environmental policies like NEPA work to protect the environment and public health by defining acceptable behavior for individuals and groups. The complexity and scope of environmental problems makes finding consensus difficult, especially when dealing with transboundary issues. The Montreal Protocol represented the first and arguably most successful international environmental policy ever produced. And perhaps a strong public voice can move climate change policy in a direction that benefits everyone.